When we learned about linear expressions, we mentioned that they're polynomials with a degree of 1. Now, we're about to discuss quadratic expressions, which are polynomials with a degree of 2. But what's a polynomial? And what does degree mean? Well, in this video, we'll take some time to define those concepts along with a few others in preparation for our upcoming videos about quadratics. So let's get to it and define polynomials. Before jumping straight into the definition of a polynomial, let's take some time to define a few other concepts first, starting with terms. A term of a polynomial is a mathematical expression containing numbers and variables combined using multiplication. Here are several examples of terms, and most of these terms can be simplified by multiplying the numerical components of the term and combining repeated variable components using exponents. Next, let's define a factor of a term as a single component of that term. Notice as we're filling in that column of our table, however, that we're leaving our numbers in their simplified form rather than splitting them to match what was in the first column. This is because many numbers can be broken down into factors in a variety of ways, so it's easiest to leave each number in its simplified form. In fact, we have a special word for this simplified numerical factor of a term, the coefficient. Thus, the coefficients of each of our terms would be as follows. Finally, let's define the degree of a term as the number of variable factors in that term. So in our first example, the degree would be 1 since the term has a single x. For the next example, though, the degree would be 3 since there's one a and two b's for 3 total variable factors. The third example might seem a little tricky since there aren't any variable factors, but that just means that the degree of that term is 0. Then, for our last 3 examples, notice that if our term has a single variable raised to an exponent, the exponent indicates the degree of the term. But if we have multiple variables with exponents, we need to add those exponents to obtain the degree. With that, we're ready to define a polynomial, which we'll say is a mathematical expression containing terms combined using addition. Another way to phrase this is that a polynomial is a sum of terms. But note that in both of these definitions, the terms we are referring to are the special terms that we just defined in the previous section. To explore this further, let's look at some examples of polynomials along with some non-examples. In our first example, notice that we have 3 terms that have been combined using addition, and each of our terms is a product of number and variable factors. In our first non-example, however, there's an issue with one of our 3 terms. Notice that 2 to the power of c can't be written as a product of number and variable factors. We can think of exponents as repeated multiplication, but since we don't know how many times to repeat the 2, this isn't a polynomial. For our next example, you might question if this is a polynomial or not, since the first 2 terms were joined with subtraction instead of addition. Notice, however, that we can easily rewrite this expression by adding the negation of the second term instead of subtracting the second term. This illustrates an important point about polynomials. It turns out that we can join our terms using addition or subtraction. But if 2 terms are joined with subtraction, we still generally think of this as adding the negation of the second term. For example, if we were asked to list out the terms in this polynomial, we would say that the terms are mn squared, negative 4n, and 13m. Additionally, the coefficient of our second term here would be negative 4, not positive 4. Then, in our next non-example, notice that we have a decimal exponent, a negative exponent, and a square root. None of these terms are achievable as a product of number and variable factors. so none of these terms could be terms of a polynomial. For our final example, we have a standard polynomial, but in our non-example column, notice that the first term contains division by x. Since terms of a polynomial must only contain numbers and variables combined using multiplication, this division is not allowed. But hold on, wasn't there also division in the example column? Well, in a sense, yes. We can think of this initial fraction as 3 divided by 5, which shouldn't be allowed in a polynomial. However, we can also think of this as a single number, 3/5, or even convert it into a decimal to emphasize that this doesn't have to be thought of as division occurring here. Instead, we're just using numbers that aren't integers. But since they're still numbers, they are allowed in a polynomial. One final note here is that our first two example polynomials contained multiple variables. While this is allowed in a polynomial, it's not something that we're going to deal with regularly in this video series. Instead, our focus will be on single variable polynomials, like this final example that only contains the variable x. So from here on, we'll stick with single variable polynomials, and a lot of times that variable is going to be x. Our next topic of discussion is going to be about the number of terms in a polynomial. This won't be a complicated topic, since we already know that terms are separated by addition or subtraction, but there are a couple important points to make. Take this polynomial, for example. We can quickly see that there are 5 terms here, but you might notice something special about some of those terms. These two, for example, both only have a single x in them, and because of this, we can combine these terms into a single term. If we have 8 x's and subtract 3 x's, that leaves us with 5 x's, which means we can rewrite the polynomial this way. From there, we can see that we also have 2 terms containing an x cubed. These terms that have the same variable component are called like terms, and they can be combined by adding or subtracting the coefficients while leaving the variable component as it is. In the end, the original polynomial simplifies to a polynomial with only 3 terms. And so in most of our discussions about this polynomial, we would say that it has 3 terms rather than 5 terms. The other important point to make here is that certain polynomials have special names based on the number of terms in that polynomial. In this first example, we can see that there is only 1 term in this polynomial, and we call that a monomial. Then, a polynomial with 2 terms is called a binomial, and one with 3 terms is called a trinomial. Now, you may be wondering how many different words you'll need to learn here, but thankfully, we don't really have commonly used special names going forward. If we have 4 terms, we can just call this a polynomial with 4 terms. And if we have 5 terms, we just call it a polynomial with 5 terms. For those of you who were hoping for more terminology to learn, though, you'll be happy to know that we also have special words to describe the degree of a polynomial. While we've already discussed what the degree of a term is, how do we determine the degree of a polynomial? Well, it's pretty simple. We just list out the degrees of the individual terms and pick the largest number. Another way of phrasing this is that the degree of a polynomial is the maximum of the degrees of its terms. To help us in determining the degree of a polynomial, it's common to write the terms of a polynomial from highest degree to lowest degree, which would look like this for our example. If the polynomial is in this form, then the degree of the polynomial is just the degree of the first term. With that, let's get to our degree terminology. If the degree of a polynomial is 0, we call it a constant polynomial, or just a constant. If the degree is 1, though, we call it linear. Next, we have a degree of 2, which we call a quadratic. This is the classification that the next several videos in this series will focus on. But since we will eventually get to polynomials with even higher degrees, let's look at a few more names for describing those polynomials. Notice that by the time we get to a degree of 4, it's common to just call it a polynomial with a degree of 4. There are still special names for those polynomials, and for even higher degrees, but you won't hear them referenced as often. To wrap things up, let's look at 2 final example polynomials and review our terminology surrounding those polynomials. In our first example, we have 2 terms with coefficients of 7 and -11 and degrees of 3 and 0. Thus, the degree of the polynomial is 3, and since it has 2 terms, we can call this a cubic binomial. For our second example, we have 3 terms with these coefficients and degrees. And since the highest degree is 2, we can call this a quadratic trinomial. That concludes this video on defining quadratic polynomials. Hope you learned something new, and thanks for watching.